Assalamualaikum warahmatullahi wabarakatuh, everyone. My name is Mohamad Hafizudin Masri. Today, I will introduce you to Truss bridge, a fascinating type of structure known for their unique design and engineering efficiency. Truss bridges are constructed using a series of F's triangles, typically with materials like wood or metal. The triangular shape plays a vital role. It's strong, stable, and resistant to distortion under stress. This makes truss bridge highly capable of withstanding external loads across large span while requiring relatively less material, making them a preferred choice among architects and engineers. There are 15 classified types of truss bridge, including Pratt, double intersection Pratt, Parker, K-Truss, Hovey, Baltimore, Warren, and many more, as shown in Figure 1. Each type has its own advantage and caters to specific engineering needs such as span length, load requirements, and environmental conditions. Selecting the right type of truss bridge is critical for ensuring durability, functionality, and safety. Focusing on the Pratt truss, it features horizontal, vertical, and diagonal members designed to evenly distribute loads. This system allows for longer spans compared to traditional beams and is often used in railways and pedestrian bridge. Typically, steel or timber is the primary material for Pratt truss bridge due to its strength and durability. As an example, the International Railway Bridge, shown in Figure 2, demonstrates the practical application of truss design. This bridge connects Buffalo, New York, and Fort Erie, Ontario, crossing the Gorge of Niagara Falls. Built in 1873, is a marvel of engineering, spanning over 1,113 meters and showcasing the strength and efficiency of truss bridge in real-world scenario. This introduction sets the stage for understanding the core principle and application of truss bridge. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Parius and I will continue our group presentation with a slide. In 1873, the Grand Trunk Railway built the International Railway Bridge for 1.5 million to address the unsafe conditions of crossing the Niagara River by boat due to strong currents and heavy cargo traffic. Designed by engineers Casimir Stanislaus Gutowski and D.L. McPherson, the bridge was a remarkable Victorian engineering achievement. It used the Pratt truss design, which efficiently handled the heavy loads of railway traffic. This innovation not only connected the USA and Canada, but also played a vital role in supporting significant freight transportation across the Niagara River.
Assalamualaikum. My name is Mohamad Khairul bin Azman. I will present about basic theory. The Pratt truss bridge use triangular element to efficiently distribute load across its structure, ensuring stability and strength while minimizing material usage. The triangular shape is key to its design, as it evenly spreads force and prevents stress concentration on any single part. Diagonal members handle tension by pulling load toward the supports, while vertical members handle compression by directly weight downward. This balance between tension and compression allows the Pratt truss to achieve a lightweight yet durable design, capable of supporting substantial load with cost efficiency. The International Railway Bridge, built in 1873, is a notable example of the Pratt truss in action. Spanning 3,651.5 feet, it connects Buffalo, New York, and Fort Erie, Ontario, serving as a vital cross-border link. Its use of the Pratt truss highlights the design's ability to handle dynamic railways load while remaining strong and economical. The bright durability and long service life underscore the reliability of the Pratt truss design, which has influenced modern engineering and continues to be a cornerstone of efficient bright construction.
Next, I'm going to present real engineering applications. Pratt trusses are commonly used in railways, pedestrian crossing, and long-span buildings ranging from 20 to 100 meters. Typically made of steel with timber as an alternative, they excel in efficiently distributing loads. For gravity loads, diagonal members are in tension, while for uplift loads, example in open structures like hangars, modified Pratt trusses are utilized. While the general run-off bridge used a steel cantilever design for its long main span, Pratt trusses could be applied in upper spans, maintenance walkways, or pedestrian pathways. These trusses often offer robust, lightweight solutions for shorter spans and secondary structures, showcasing their efficiency and versatility in enhancing the bridge's functionality and stability.
Thank you. Now, let us proceed with discussion. The Pratt Truss Bridge is one of the most commonly used structural designs in engineering due to its strength, efficiency, and effectiveness of cost. This discussion will touch on the geometrical aspect of the design and load distribution, as well as Pratt Truss Bridge's relation to the principle of statics. Application of statics principles. The Pratt Truss is in running order on the principles of static equilibrium. This structural system gives an explanation that all forces acting on the structure must be in balance. This is recognized through satisfaction of three fundamental equations of equilibrium. These principles provide certainty that each joint or node in the truss remains in a stable and immobile one's position under load, without any form of deformation or failure. Geometric design and load distribution. The Pratt Truss Bridge is characterized by its triangular geometry, which imparts stability and strength. Due to the character of a triangle being inherently rigid, the load is appropriately distributed across the structure. As the truss structure is subjected to a load, the forces are transmitted through the truss members, consisting of diagonal members experiencing tension, pulling forces towards supports. At the same instant, vertical members endure compression, transferring forces downward. This arrangement prevents any single member from being overstressed, in consequence ensuring stability and durability. Force and moment analysis. To identify the forces in the truss member, two methods are generally used. One of it is joint method. The joint method views each joint as essentially a point of equilibrium in order to calculate the forces in the members connected to that joint. This is thoroughly suitable for a simple design of truss. Other than that, section method. The section method cuts through specific members to analyze sections of the truss, providing insight into internal forces, particularly in complex truss configurations. Moments, which are a measure of rotational effects caused by forces acting at a distance from the pivot point, are used in calculation as well. An understanding of moments allows engineers to locate and quantify stresses within the truss, ensuring stability and structural integrity. Material efficiency. Pratt truss is remarkable for its efficiency in the use of material. In spite of its strength to withstand heavy loads, Pratt truss is also known for its lightweightness. This is made possible because of the differences of placement of each member, which are placed at positions where they could bear the specific kind of force, tension, or compression. Free body diagram. The reasons of drawing free body diagram, or FBD, includes visualizing force. FBD provides a clear representation of all the external forces acting on a bridge and its component. This helps understand how these forces interact and affect the stability of the structure. Other than that, simplify complex structure. FBD simplifies this complexity by isolating individual components and showing how forces are transmitted through the truss, particularly for complex structures with many interconnected members. Moreover, determine reactions and internal forces. Engineers can calculate the reactions at the supports and then use these reactions to calculate the internal forces in each member of the truss through the analysis of FBD. Type of support. The Pratt truss bridge typically uses both pin and roller supports to provide stability to the structure, as well as accommodate such movements as those due to thermal expansion and contraction. Pin supports resist both horizontal and vertical, while roller supports resist vertical but allow horizontal movement. The combination in this structure keeps the truss stable for a variety of loads without developing undue stresses. Zero force members. Zero force members in Pratt truss may be identified by the following criteria. If two non-collinear members are meeting at a joint that does not have any external load or support, these two members are zero force members. Other than that, members that will not contribute under symmetric structure and symmetric loading to the transmission of force through them are also zero force members. These members under ordinary conditions will not carry a load, but for the stability and added safety due to unexpected conditions of loading on the structure. Identification of tension and compression. The members of the Pratt truss can be identified either in tension or in compression, depending on the direction of force transmission. Diagonal members directed toward the supports are in tension, and vertical members bear compressive forces because of the transmission of forces in a downward direction. In fact, all these forces have been worked out from the analysis of the equilibrium equations, so that each member is designed to resist the kind of force coming onto it. Selection of analysis method. The most appropriate methodology for the analysis of the Pratt truss railway bridge will be the method of joints. In this methodology, it is assumed that every joint is at equilibrium for the calculation of the internal forces of the members meeting at that joint. The Pratt truss structure, with its regular and symmetric triangular geometry, allows this methodology because of the simplicity of its layout and the ease with which the application of equilibrium equations can be effected. Taking everything into account, the Pratt truss is cost-effective for a variety of applications requiring high performance and durability, thanks to its geometric strength, equilibrium principles, and material optimization. By using free body diagrams or FBD, engineers can visualize forces, simplify complex structures, and accurately analyze internal forces such as tension and compression. The combination of pin and roller supports ensures stability and accommodates movements from thermal expansion and contraction. Additionally, zero force members enhance safety by maintaining the structure's integrity under unforeseen loading conditions. The method of joints, chosen for its ease of application and accuracy in calculating forces, provides detailed insights into the truss's performance, making the Pratt truss a reliable practical choice for bridge construction. Thank you!
I will continue. Allow me to conclude of some of the salient features regarding Pratt truss bridge. In reality, they are pretty brilliant because of their efficiency, strength and stability. Their triangular geometry offers balance when loading diagonal members take up the tension and the vertical members deal with compression. With such strategic design, no element is overly strained, hence elongating the life of the bridge. By fundamentally implementing the principles of statics with regard to the equilibrium equation and analysis of force, the Pratt truss provides good distribution of force and stability concerning the applied loads. Besides, its material efficiency is amazing. Members are placed in such a way that they resist specific force, giving great strength with a minimum amount of material used. This makes the Pratt truss lightweight yet highly durable, perfect for a variety of engineering applications. This is the case in a properly designed Pratt truss bridge. It will not only be safe from a structural viewpoint but economically viable. Essentially, this is engineering actually how appealingly creative design may be brought to solution making for everyday real problems. That's all from us. Thank you.